Carlos and Monica collect baseball cards. Carlos has 7 more baseball cards than Monica has. They have 73 baseball cards in total. How many baseball cards does each person have? All right, we've read the problem. If you don't understand the problem yet, you can reread it again. But basically, we're looking to figure out how many baseball cards Carlos has and how many baseball cards Monica has using the information we're given. Now, we have 2 unknowns here, which is different from the previous problems. In the previous problems, there was one thing we were trying to find, but now there's 2. So under step 2 for our let statements, we're going to have 2 of those let statements. Here's what I'm going to do. I'm going to write the beginning of each of these statements. So let Carlos's cards be, and I'm going to leave this blank for a minute. You'll see why in a second. And also the other unknown is Monica's cards. All right, so we're going to have 2 let statements. We can't let them both be X. If we did that, that would assume that they have the same number of cards. But that's not the case. Carlos has 7 more cards than Monica has. We also can't let one of them be X and the other one be Y, because we haven't yet figured out how to solve word problems where there's more than one variable. That involves systems of equations, which we're going to be looking at in the future. So what we need to do is we need to let one of these be X, could be Carlos, could be Monica, and then we have to write the other one in terms of X. This is a strategy that you're going to get better with practice. But here's what we're going to do. Let's look at the part where they compare Carlos's cards and Monica's cards. They say Carlos has 7 more baseball cards than Monica does. So they tell us something about Carlos based on what Monica has. Because we know nothing about Monica, but we do know something about Carlos, we're going to let Monica's cards be X. So Monica's cards here is going to be X. Now, when we're figuring out how to represent Carlos's cards, we know that Carlos has 7 more than Monica. Well, if Monica has X cards, how do we represent 7 more than that? X plus 7. Aha! This is the trick. We're going to let one of those unknowns be X, and then we're going to write the other unknowns in terms of X. In this case, it was X plus 7. If Carlos had 7 fewer baseball cards than Monica, it would be X minus 7. If Carlos had 7 times as many cards as Monica, it would be 7 times X. But basically, we need to let one of them be X and write the other ones in terms of X. And the one that's going to be X is always the one that we don't have any information about. All right, now that we have our let statements, we can move on to step 3, write an equation that models the situation. The piece of information we haven't used yet is that they have 73 baseball cards in total. So if we take Carlos's cards, which is X plus 7, and we add to that Monica's cards, which is X, we know the total has to be 73. Now, once we've gotten to this point, we have an equation, and we can solve the equation so that we can state the conclusion. To solve this, we need to combine the x's on the left. That gives us 2x plus 7 equals 73. Now we want to get the x term alone, so we've got to get rid of this 7. We can do that by subtracting 7 on both sides. Leaves us with 2x on the left. 73 minus 7 is 66. And then to get x alone, we divide both sides by 2. This tells us that x is 33. Now we're not finished because the problem doesn't say what's x. The problem says how many baseball cards does each person have? So we go back to our let statements. Monica's cards was represented with x, and we know that's 33. Carlos's cards were represented by x plus 7, and so here we can plug in 33 plus 7. That gives us 40. So our conclusion is going to be that Carlos had 40 cards and Monica had 33. And that's our conclusion. If we want to check it, we can check it in the original problem. It says Carlos has 7 more baseball cards than Monica has. Well, that's true. 40 is 7 more than 33. It also says they have 73 baseball cards in total. If we add these up, we get 73. So because this satisfies the situation, we know that we've solved it correctly, and this is our final answer.